Good morning, everyone. My name is Barb Ryan, and I'm the Executive Director of the World Geospatial Industry Council, WGIC. And I've got a few slides at the end of the presentation that talk about that organization. But I'm here this morning to talk about supporting decision makers, challenges and opportunities for the Earth observation and geospatial communities. And I can tell you I'm really excited about being here. One, it's a great event, and I want to thank the sponsors, the organizers. John, you and your team have done a great job, and of course you in the audience. You know, it's really quite a feat during these times to put an event of this order of magnitude on virtually, and so again, thanks to everyone for joining. So let's go ahead and get into the presentation. An overview of the talk, just real quickly, I'd like to spend a little time talking about enabling conditions, challenges and opportunities, and then a proposed way forward. And, you know, from the talks that have already taken place this week, a number of these issues have already been discussed. I guess what I'd like to do is hopefully kind of weave them together into, I hope, what is a coherent presentation. So let's talk about enabling conditions. For me, there are a couple. Open data, which is just really so important for public institutions. That is, those institutions that have used taxpayer money to collect data. And I'll spend a fair amount of time talking about that. Build on what's been done rather than reinventing the wheel. Let's take advantage of the innovations that have already occurred. And then, of course, better integration and coordination, and linked to that coordination is something that we'll just call hyper-partnering. And then lastly, just the linkages to policy mandates, whether it's the Paris Accord or the Paris Agreement, the Sendai Framework, and or the UN Sustainable Development Goals, those SDGs. So let's go right to open data and advocacy for open data. You know, I feel quite strongly about this, and the next couple slides are going to talk about some experience that I had while I was at the U.S. Geological Survey, you know, where I spent most of my career, actually 34 years with that organization. But there was a period from 2000 to 2008 where I was Associate Director for Geography, and so I had responsibility for the geographic and land satellite remote sensing programs for the organization, and that was largely the Landsat program. So in that program, the first Landsat satellite was launched in 1972. And for 30 plus years, the data was sold. Now this graph starts at 2008. So if you follow that graph back to 1972, you could see that it would be a flat line from 1972 all the way to 2008 because 53 scenes a day were sold. Now that actually even dipped lower than 53 scenes a day in the mid-80s when the private sector took over the satellite because the price increased by an order of magnitude. When the Geological Survey or the government operated the satellite, Landsat scenes sold for $400 or $500 a scene. It jumped to $4,000 or $5,000 a scene in the mid-80s. And then, of course, after almost no scenes were sold, it transitioned back to the federal government. And then just for context, NASA builds and launches the satellites, and because this was largely an Earth observing satellite, landmass satellite, land natural resources, then it was the Department of Interior and the Geological Survey who operates the satellite. To this day, they operate the Landsat series of satellites. And I have to say, from 1972 up to 2008, there were many people that were advocating for broad open data policies from the beginning of the program, and just for a number of reasons. I don't think the resources certainly weren't there when you had to distribute scenes, mailing those scenes out, or sending discs with those scenes out. And so it really was kind of a combination of factors. Certainly the internet, facilitated by the internet, where you were then distributing scenes over the internet. And there was a regulation in place in the US called, there still is, called COFR, the Cost of Fulfilling User Requests. And so government agencies can't pass the cost of products on to users for anything other than the incremental cost to get that image or scene or data or spreadsheet, whatever it is, out the door. That is, you can't build into that distribution cost the cost of the satellite or the cost of your distribution mechanism. It's only the incremental cost to get the scene out the door. So that's where you can see that with technology, it was difficult to show that it was $400 or $500 a scene to do an incremental scene to get it out the door. The other key factor was we did an analysis of who's buying those 53 scenes a day. Well, it turned out, number one was the federal government, that is other government agencies, in particular the Department of Agriculture. Number two, universities that were largely funded by government agencies, National Science Foundation or other state and local organizations. And then thirdly, contractors that were largely financed by the Defense Department. So while the Geological Survey was collecting, we were collecting $4.5 or $5 million a year, which, by the way, is not chump change. It still wasn't a good investment for the federal government. We were taking money out of one pocket and putting it into another pocket. So anyway, we finally were able to go forward to Congress, to the Office of Management and Budget, ultimately to the White House to get the policy changed. It changed at the end of 2007 or 2008. And this graph shows what happened after that policy change. A 2 order of magnitude increase, 53 scenes a day, up to 5,700 scenes a day. To this day, our Landsat scenes being distributed out the door. So a tremendous, tremendous increase in the uptake and usage of the information from that satellite. Now, but that's not the end of the story. I retired in 2008 from the Geological Survey before going to Geneva, Switzerland. But in 2011, an economic analysis was done that showed there was $1.7 billion of annual economic benefit that accrued from this policy change for just Landsat in the United States, $400 million elsewhere, and $2.1 billion. So for a total of $2.1 billion globally. Now, we knew that there was going to be more economic benefit than the cost that we were accruing, the data sales costs of $4.5 or $5 million. But I don't think any of us expected it to be this much more, $2.1 billion. And I understand from the Geological Survey, with some more recent estimates, these numbers have these numbers have increased. So billions of dollars of economic benefit from broad open data policies. Now listen, this is just one satellite series, one government agency. Can you imagine if all governments, whether it's their Earth observation satellite data, whether it's their geospatial data, whether it's cadastral data, statistical data, stream gauging data, soil moisture data. Can you imagine the economic benefit that would accrue from having government data be broadly and openly available? How does that happen? Universities no longer have to pay for the data, so their grant dollars go farther. The private sector, most importantly, comes in and builds value-added products and services. So before, where they would have had to build the cost for $500 a scene for Landsat data into their value-added products and services, that cost is no longer a part of their processing scheme. So that's how economic benefits are accrued from broad open data policies on the government side. One other example comes a little bit closer to home for you folks here in Canada. This is graph from 96 to 97 up to 2012 or 2013. I'm sure this has been updated, but I understand there was a policy change between RadarSat 1 and RadarSat 2, where at least with one of the satellites in the 2005-2006 era, the RadarSat was at least given to the government at no additional charge. And what you see here is a 1 order of magnitude increase, about 5,000 scenes a year up to 45,000 scenes a year. So almost a 1 order of magnitude increase. Again, I would say now, understand this may not have been a public asset, but what I'm advocating is that if government agencies are even using tax dollars to buy scenes, then all taxpayers ought to benefit from that procurement. So that's just a quick story about broad open data policies in both the United States and Canada, with a couple examples there. When I talk about what's been done, let's build on what's been done. It'll still focus on Landsat, but we're going to bring in the Sentinel series of satellites, and we're going to move down to Australia. So what you will see in this animation is that Australia, the government of Australia, Geosciences Australia, and their partners, the National Computer Center, ingested the entire Landsat archive for the continent of Australia into their National Computer Center, and then put an algorithm in place, essentially, that is going to look at pixel by pixel, not scene by scene, but pixel by pixel inside that entire Landsat archive for where there was a pixel, that's 25-meter square area, was always covered by water, a pixel that was sometimes covered by water, sometimes not, and a pixel that was always dry. And so you can see the amazing analysis that was able to be done at a landscape scale, pixel by pixel, not scene by scene, by being able to drill down through that entire Landsat archive. They're now bringing Sentinel data into the same setup. And for me, if we as a community could actually build on what they've done, then that would be amazing. And it's not just a water algorithm. Can you imagine if we could look at the entire Earth pixel by pixel for changes in urban footprints, for changes in forest cover, for agricultural purposes? I mean, we really would have an amazing analytical ability with this data that's now ingested. In the case of Australia, it was into their National Computer Center, but for many other countries, they're just storing this data in the cloud. So in addition to showing that histogram of those pixels over the entire continent that were, you know, always wet, always dry, sometimes wet or sometimes dry, here are some summary statistics for the Australian data cube. 27 years of data, 25-meter pixel resolution, 300,000 scenes were ingested into their computer system, and that's 20,000 passes of the Landsat satellite over the continent of Australia. And then with that water algorithm, 3 hours of compute time. So just an amazing capability. And again, wouldn't it be something if we had that one globally, but for many other parameters for landscape change over the Earth? Australia, I may have mentioned this, Africa is doing an African data cube. Other countries are coming close. They're putting all the data in the cloud and then having search techniques to go through that entire archive. But again, making the transition so that we can actually show policymakers what we're doing here is just so important. Let's go to better integration and coordination. clearly within our respective organizations, that's internally, nationally, between and among our respective national entities. Again, I think this is what has been so good about that Australia example. It was Geosciences Australia, it was the Space Organization, CSIRO, it was the National Computer Center, likely all within different ministries, and yet they got together to do a continental scale analysis of water in their on the continent. Regionally, so continent-wide efforts. Happens to be one country with Australia, but it was a continent-wide effort, which I think sets a really good example for other continents around the world. And then globally, and the role that international organizations play, particularly in those policy mandates, Paris, Sendai, or the SDGs, are really important. You know, a related issue on that coordination is just hyper-partnering. I think it was actually the Association of Investigative Journalists that came up with this terminology, hyper-partnering. But for me, it's so relevant to our community. That is partnering with academia, not-for-profit organizations, the public sector, and the private sector. I had a great conversation earlier this week with John Neufeld and Matt Sheehan talking about a global accelerator, where even within the private sector, small companies could be partnered with larger companies for mentoring and for investing in new startups. So there's just so much potential if we start thinking about hyper partnering. Now, it's time consuming. It takes a lot of work to work with other organizations. It's so much easier just kind of to stay in your cubicle and do your own work. But if we really want to advance this field, we've got to move farther down this line. So just the last couple slides, we'll talk about WGIC. We're a global not-for-profit trade association of private sector companies working in the geospatial ecosystem. So you've got to be a private sector entity, could be Earth observations, our satellite companies, our equipment manufacturers, down to small and medium-sized enterprises and startups, anyone working in the geospatial ecosystem, and it's a broad ecosystem. We'd love to have a conversation with you. To the best of my knowledge, WGIC is the first global trade association. We've got wonderful examples of regional and or national examples. In the United States, we have MAPS, the Management Association for Private Photogrammetrists and Surveyors. In Europe, we've got the European Association of Remote Sensing Companies. In India, excuse me, we have AGI. So if we globally could start partnering with those regional associations, again, for advocacy of our entire industry, I think it would be it would be a good step forward. Our companies are shown here. You'll see companies, some of the largest in the world, to just small and medium-sized enterprises. We want to bring diversity of thought to the whole organization, and we also want to bring a geographic diversity. We have no members from South America. We have just a couple members from Africa. So again, we'd really like to just increase the diversity, not only racially, from a gender perspective, but geographically, and diversity of thought also. We also work with partners, and you'll see a couple that are shown here. We just recently had a partnership with ITU, the International Telecommunication Union, to release an AI ML report. I've got a link for that report in a slide or two. The United Nations Statistic Division, particularly on delivering SDGs. So there just are so many organizations that are working in this trade space, and we'd like to reach out and partner with them as opportunities arise. So later in this GeoIgnite conference, there'll be a WGIC workshop of 1 o'clock on Friday, April 30th. We would love you to join us. You'll learn more about WGIC and the advocacy efforts for the geospatial industry. We'll also do a little deeper dive into this report that we just released. I mentioned it earlier. Access the report at this link. It's Geospatial AI ML applications and policies, a global perspective, where we did research across the globe in looking at policies that affect AI ML. And I'd also like to take this opportunity to just do a shout out to Einar Bogner, who's at UNISAT in Geneva, Switzerland. He recently had a post on both LinkedIn and Twitter about why has satellite imagery kind of lagged in terms of being really taken up. And of course, I responded that I still think it has a lot to do with government agencies around the world have not adopted broad and open data policies so that the private sector can come in and add value-added products and services to that data. Einar makes an argument that AI ML may be the next real innovation that will advance this field. So our report turns out to be very timely at that perspective. So I think with that, I would just like to end with a saying that has meant a lot to me. Countries have borders, Earth observations don't. You will not talk to any astronauts that have traveled in space, looked back at the Earth, and every single one has commented, you know, we don't see national boundaries. We just see the Earth as an interconnected planet, and that is so important for us as we go forward. So I'll end there, and I'd be happy to spend some time with questions and hopefully answers. Again, thank you, sponsors, thank you, organizers, and most importantly, thank you in the audience for taking time to join us this morning. Bye-bye.
Oh, thank you so much, Barb, for that talk. That was fantastic. I really appreciated you going into some of the details on the Landsat and tying it into other programs and looking at Australia. There was something I wanted to ask you about in terms of open data policies and governments. It looks like Canada would like, our government would like to start heading in that direction. Can you talk a little bit about maybe some of the reasons why? Because maybe the audience doesn't understand, like, why wouldn't every government say, we own the data, it was paid for by you know, our citizens, why don't we just make it open? Why is it maybe, you know, not easy to just go ahead and do that?
Yeah, well, that's actually a good question, John, because I think talking to any government agency that doesn't share data, they got 1,000 reasons on why they don't want to share data, which is one of the largest problems. I can tell you that from within the Geological Survey, I'd argue probably for almost any agency, if you are taking in $4.5 or $5 million a year, or even less. I've talked to government agencies that are making $100,000 a year on selling data, and they don't want to give up that $100,000. And so I think that's probably the largest, the biggest reason you'll hear. We heard reasons about privacy, you know, this person shouldn't have access to that data. Early on in the Landsat era, we were worried about other non-friendly partners coming in and having access to the entire US data set. And so really you'll hear a lot of reasons for it. But I guess for me, and you saw it in the talk, that economic benefit, that can, not only the economic benefit, but the scientific and the scientific analysis that can be done back for your own country or for the Earth at large is just so important. And we tend not to put an economic number on that kind of work. You know, we only look at it in terms of dollars and cents. About what money is coming into our pocket right now. So I think those were the big reasons that were given when we were trying to change the policy.
Great. Well, I think you've stirred some interest from the participants. I see the Q&A is picked up, and we've got our first questions coming in. I'm going to set this one to answer live from Aaron. I'll read it out.
Okay.
Given that higher resolution satellite data is licensed to private companies and costs more for broad sharing, it is almost impossible to make it open. How would you propose governments go about making these collections more available?
Mm-hmm. Yeah, and I want to be really clear that my advocacy is really targeted at government, public institutions that are using taxpayers' money to build these assets, okay? So that's the target audience for most of this talk. Clearly, the private sector entities, and those are growing more and more with small satellites coming into the picture, have a different business model, and I totally respect and understand that different business model. What I would say is if a government agency, and let's take the example of Norway, has just paid Planet $100 million for planet data, I think over rainforest areas, tropical forest areas, maybe all forest areas. And so the government of Norway negotiated that deal with the condition that all of that data had to be broadly and openly available. So the point there is the government has a fair amount of pull in this effort if you are using taxpayer money. Now, there may be an uplift charge to make it broadly and openly available, but governments have more influence than I think they're actually invoking in this entire area. Whether it's high resolution, low resolution, hyperspectral, it doesn't really matter to me what the sensor is observing. It's more of an economic argument with taxpayer money.
Well said. I'm going to close that one. And we've got one here from Peter. Thank you, Peter. Water availability is a national issue in Australia, and water is relatively easy product for Landsat. What are other North American or other continental issues? And do we have yet the time series, spatial and spectral technologies in orbit to as easily tackle them?
Mm-hmm. Yeah, well, listen, I do think there are certainly challenges, but we're starting to see every year more parts of the spectrum being observed from space. I'm not saying that you'll have continental coverage for every single issue. For, if you've got a hyperspectral sensor, it may be targeted, it may not be on an Earth observing satellite. But let's, and the data cube that Australia did was just optical imagery, okay? It was Sentinel and Landsat data. But just even from an optical perspective, we can look at urban change, we can look at urban growth, with an implied population growth to that area. We can look at forests, we can look at agriculture. So any landscape change that can be observed from space, I think is important to move into that technology.
Okay, I'm going to close that one from Peter. We've got one from Jeff Zeiss. Is there an open market for satellite imagery that ultimately will drive the price of data down, given the amount of new data is increasing from terabytes per day to petabytes per day?
Yeah, I think so. I think, Jeff, if I understand the question, I don't know what kind of impact that's going to have on the private sector yet. It'll depend on, for me, it'll depend on how many governments are coming in to actually buying that. I think there will always be high bidders out there that want to have access to that data from the private sector, whether it's more timely data or more or targeted areas where that price will stay fairly high. Because the truth of the matter is it's still an expensive business, to build and launch a satellite. You're seeing changes now with launch costs coming down. And in fact, I think I think many people are saying that's the most substantial piece that's got to come down if this whole industry is going to become more accessible. But, I guess that's what I would say. Certainly for government assets, the price will come down. I'm arguing it should go to zero. Okay. For the private sector, I don't know. I don't know. I think there's still, I think you're going to have you're going to have some workhorses. Landsat and Sentinel satellites are always going to be a workhorse for global Earth observations. And where I think this private sector is doing a phenomenal job are coming in with more targeted, either higher spatial resolution, video from space, more temporal, or different sensors for greenhouse gases, for example, or methane. We're going to see that as we go forward. So I guess that's all I would say. Jeff probably will have some other questions on that. Okay. John, there is one other thing I want to say, because I did see a comment early about, well, don't we have Google Earth Engine? Mm-hmm. And listen, Google Earth Engine is a phenomenal tool. You know, if we had Rebecca here, she'd say Google Earth Engine, the Landsat policy, in fact, facilitated the development of Google Earth Engine. And now Sentinel's going into Google Earth Engine. I would argue it's still largely researchers that are going in and using that capability. I don't think we have quite the data cube analysis that Australia had in a Google Earth Engine yet. And again, if Rebecca was here, she might, you know, challenge that. But for me, it's still a relatively small number of people. It's not fully woven into the fabric of our work. And quite honestly, there are some countries around the world that may not want to use or rely on a US company for their analysis. And that's why I'm saying continent by continent, we ought to build this up so that all governments have access to that same information.
Makes sense. Thank you. So we have time for one more question because we're already into the break. So it's from Kelsey. Barbara, we have heard from other speakers that one key part of advocacy in our sector is to change the messaging to focus more on real-world problems and mainstream business terminology that is more familiar to the masses rather than the usual technical language we use to describe what we do as geospatial professionals. What are your thoughts?
Yeah, no, I couldn't agree more. I think and I understand there was a real lively discussion yesterday afternoon. I didn't catch it, but I agree entirely. And, you know, I think it's not just the Earth observation community. I can tell you as a scientist, we are always more comfortable talking about how we do something than why we do something. And it's really hard to jump to that end, to one, simplify the story, and then jump to the end goal or the end reason why we're doing this. John, if we have just one more minute, sure. I have a wonderful example. When I worked for the Geological Survey, we had one stream gauge measurement that was taken in 1898, and it was being challenged by a development firm that wanted to construct a large housing development in a floodplain, okay? And so they challenged that stream gauge measurement because, you know, it determined whether the housing development was in or out of the floodplain. So we sent in our surface water expert, you know, who absolutely knew this story inside and out. And of course, the policymakers were saying to him, they go, listen, they're going to want a black or a white answer, black or white, full stop. And of course, it was eggshell or mauve or beige. And he, as a scientist, could not say it's white. Because it wasn't, it was beige. Now, it was a whole lot closer to white than to black, but as a scientist, we want to be precise and we need to be precise, but policymakers are going to make decisions on whether we give them an answer or not. And I think we have a responsibility to at least do a better job of communicating risk, because had that housing development had been built and flooded, then what was the loss of life and property in that particular instance? And so for me, that's, you know, scientists, you have to love them, but that's a big issue that we face. It's really hard to give definitive answers, and people don't understand risk enough. And I don't think we communicate it in easy enough terms to say, you know, here are the error bars around my answer.
Okay. Perfect. Well, thank you very much, Barb. And yeah, everybody check out the workshop schedule. The WGIC is in there. You're going to be able to talk to them about what they're doing and their advocacy and maybe potentially participating in that.
Right. We'd love to have you there.
Great. Thank you, Barb.